Hey Matrix, welcome back to the next video in the playlist where we're going over Maths Paper 2 2020 November past paper. If you don't have the paper, there's a link in the description below where you can download the paper as well as the memo, and once you have the paper we can continue with the question. Okay, let's look at question 7. So question 7 has got to do with trigonometry still, and we're looking at triangles, so we're going to apply trig to some triangles here. So it says a landscape artist plans to plant flowers within two concentric circles around a vertical light pole PQ. Okay, and then they've given you the diagram below. So flowers are going to be planted around here, and that's your light pole. So they also give you here that the radius of the small circle is r. They don't give us the radius of the big circle, which means you're probably going to have to calculate it. They tell us this angle here is 30 degrees, and they also tell us that Q or RQS is given as 2x. Okay, and then they've given the height of the pole. So the first question, 7.1, says show that QS is equal to 3r. Okay, so note that QS is part of this big triangle, but also the small triangle. But if we look here, the small triangle at the bottom here doesn't really give us enough information. We don't have the angle size there, it's just 2x. We don't have anything else. So I'm going to be working with Q, P, and S. Okay, so what I've done is I've drawn Q, P, and S flat here. Okay, so we've got 30 degrees. If you want, you can go and calculate that. It's not necessary, but you can see that this should be 60 degrees. Okay, and they want this length here. Okay, so we can think about it. This here is y, and this here is x. Okay, so we need the x value and we have the y value, which means the trigonometric function we should be thinking of is tan. Okay, so I'm standing over here and I'm going to be using my tan function. So it's going to be tan of 30 degrees is going to equal to y. Remember, it's y over x. Okay, which means I'm then going to have the square root of 3r all over QS. Okay, and tan of 30 degrees, if you remember from your special angles, that's going to give you 1 over, sorry, not 1 over root 3, it's just going to give you root 3. Let's just check. It's 1 over root 3. Okay, mistakes here. 1 over root 3. Okay, now we need QS on its own. So I'm going to take QS that side, I'm going to take 1 over 3 this side. So I'm going to have QS equals to root 3r all over 1 over root 3. Okay, because it's a fraction within a fraction, this goes to the top. So root 3, remember that if I have root a multiplied by root a, it's going to give me a. Okay, so same thing's going to happen here, and I'm going to end up with 3r. Okay, so I've shown that QS equals 3r. Okay, then 7.2 says determine in terms of r the area of the flower garden. Okay, so that is this area here, this shaded area between the two circles. Okay, so we know that the area of a circle is given as pi r squared. Okay, and we've just calculated the radius of our big circle, that's QS. Okay, so alpha here, which I've indicated as the radius of the big circle, is going to be 3r. Okay, so the area of the flower bed, so I'm going to refer to it as a flower, is going to then equal to pi r squared. Okay, so we can call that big R for the outer one, minus the inner circle, so that's going to be pi little r squared. Okay, so we know that big R, so we can say that R is equal to alpha, which equals to 3r, so that's going to be pi 3r squared minus pi r squared. Okay, this is going to be 9 pi r squared minus pi r squared, which means we're going to have 8 pi r squared as this area over here. Okay, so we're taking the little circle out of the big circle and we're left with that shaded area. Okay, now 7.3 says show that rs equals to r times the square root of 10 minus 6 cos 2x. Okay, which means rs is attached to this bottom triangle over here. Okay, so I've taken that out and I've redrawn it over here. So we have RS, we have R given here, and we now know what QS is. So like I've always said before, once we've found something, go fill it in on our paper. So we don't have to look through our calculations for what it is. Okay, so we know that QS is now 3R. Okay, and note that I don't have this angle and I don't have this angle, so I can't use the sine rule. But I have two sides and one angle, which means you should be thinking of the cos rule. Okay, so we're going to use the cos rule. Okay, so I'm going to be using the cos rule to find RS. So RS is what I want, so it's RS squared equals to each side squared. So I'm going to say RQ squared plus QS squared. Okay, then we minus 2 times the length of each side, so RQ QS, okay, and then cos of my angle that's given, and that's 2x. Okay, now I just need to apply some algebra in order to simplify everything. So I'm first going to substitute in what RQ and QS is. That's what's given over there. So RS squared equals to, let's see, R squared plus 3R squared, which is going to give me 9R squared, minus, let's see, that's R is going to go in there, 3R is going to go in there, so that should give you 6R squared cos of 2x. Okay, now it's all about just sorting everything out. We can see that this and this is going to add, which is going to give me the 10 I'm looking for, and I've already got the 6 I'm looking for. So RS is then going to equal to 10R squared minus 6R squared cos of 2x. Okay, we can take R squared out as a common factor, which is then going to be R squared 10 minus 6 cos 2x. Okay, and then I can square the whole thing. Now remember, when I square root something that's squared, so if I take the square root of a squared, it's equivalent to plus or minus a. But in this case, we can't have a negative length. Okay, we're taking the absolute value. So if I take the absolute value of a negative value, it's just going to give me the value back, okay, the positive value of it. So by taking the absolute value of that, we're going to end up with just R on the outside, okay, once I've square rooted both sides, so RS, and then I'll have square root of 10 minus 6 cos 2x. Okay, and I've ended up with what I was looking for. Okay, now finally 7.4 says if R is equal to 10 meters and X is equal to 56 degrees, calculate RS. Okay, so now we have the formula for RS. All we have to do is substitute in the values. So over here, 7.4, okay, using what we have in 7.3, it's going to be RS is going to equal to 10 square root of 10 minus 6 cos of 2 times 56. Okay, and if we plug that into your calculator, you should get to approximately 35 meters. Just double check my answer there. There we go. Okay, so your answer should come down to 35 meters. And that's how we go about doing this question. Okay, if you found today's video helpful, then please leave a thumbs up on the video. If you have any questions or comments regarding this question, question 7, please leave them in the comment section down below and I'll get back to them as soon as I can. Please go check out the channel. There's physics and chemistry videos as well as maths paper 1 videos. While you're there, please consider subscribing. And remember, it's never too late to have an OIC moment.